Hello everyone. Today we're gonna solve the path sum 3 problems. This problem gives us a binary tree. The numbers are odd. Need to find a path from the parents, their children, that we can get the target sum path. So we know that the path then does not need to start and end at the root or a leaf, but it should be downward. So to do that, first of all, we can think about a way to store the sum. And one of the way I can think about it is that we're gonna use a prefix sum from a root to a node. For example, we can think about in this example, we can store the prefix sum from the root node to each of the nodes. For example, node to itself is 10, a root node to 5 is 15, and root node to this one is 15, and the root node to this one is 21. And when we meet this problem, we can ask the interviewer about the value of each of the node. So if we have, for example, we can ask like, do we have any negative number? And in this case, obviously, one is negative. And we can ask them like, do we have any floating numbers like 1.5 or something? And if we have this kind of number, it's going to be harder to solve this problem. Luckily, we don't have those kind of number. Just have a integer number. And then, so why we store these the prefix sum like this? So the reason is that uh, we can use binary search to for a target sum for each of the prefix sum. In this case, if we have the target is 8, at each point, we're gonna search for example, in this case, we can see how many prefix sum equal to 21 minus by 8, which means that we can just count the frequency of the 13 prefix sum, right? And at this point, we see that we don't have any this 13th case, and do the same for this one. In search for 18 minus 8 and we saw that we have one term, which means that the path from the child of this node to the current node we consider will have the sum 8. So we're gonna do the same for this one. We have in 17. This one is 15, right? So we're gonna do the same here. At this point, 18 minus by 10, no, 18 minus 8 equal to 10. We see that there is 1/10 prefix sum over here. So we know that the path from here a valid path. We're gonna do the same right here. Have 10. This one is some here. It's gonna be in same case happened right here. That's basically the now we're gonna go to the implementation path. First of all, we're gonna frequency of the prefix sum. Then we're gonna use as out to count a path sum. Then gonna have to consider the path sum of the root and a target sum. So let's say then we're gonna consider if we have a root equal to null pointer. This is can just return 0. This is a corner case, and then we're gonna just add sum from our root with a target sum. Then we need a variable to store current prefix sum. At the first place, the current 0, and of course the prefix sum's frequency of the prefix sum 0 gonna be equal to 1. This is like the base case of algorithm. Then we're gonna implement as out path sum right here, root, target sum, and current sum, or target sum, current sum. Then we're gonna have current prefix sum plus without value, root value, and then we're gonna increase our result by the prefix sum of the current prefix sum, the prefix sum minus our target sum. So it's similar to this case, like when we have the current frequency right here, right? And we minus with the target sum, and we consider frequency of this formula. We consider the frequency of is similar to what we are doing, and then gonna have uh, gonna increase the frequency of pixel, our current pixel by 1, and we do something here. Then finally, after the DFS, we need to minus by 1. Make sure that return the original state or the fixed frequency prefix sum, right? Right now, go to the left and go to the right node. Right? We have left. We're gonna do right node here. DFS to the left and right, right. Yes, plus with uh, negative current. Right. Yeah, yeah. And time complexity for this one. O and base complexity n as well. With n is above node. Have the topic for this one. E, V, and pointers. and maybe prefixum as well. Perfect. Because we have here right here, so we should change it to perfect, and we solve this problem. And that's all for this problem, and hope you guys can solve it. And if you have any question, just leave it below.